Hey guys, welcome to Intellipaat. Cloud computing has revolutionized the way we think about building, deploying, managing and scaling our applications, services and infrastructure. There has been no industry that has not been impacted by cloud computing. Some of the major companies have completely moved away from on-premise infrastructures to cloud computing. But how do we get started with cloud computing and how do you become a cloud engineer? To help you understand these questions, we have come up with this video. Before we start, do subscribe to Intellipaat's YouTube channel so that you never miss out on our upcoming videos. Now let me walk you through the agenda for today's video. We will begin with understanding what cloud computing is and its advantages. Then we will look at some of the products that are built by cloud computing. After which we will learn about deployment and service models in cloud computing. Post which we will get some hands-on experience on creating, launching servers on cloud providers like AWS and Azure. After which we have a good understanding about who a cloud engineer is, the roles and responsibilities of a cloud engineer, and the skills required to become one. Finally, we would be giving you the most important interview questions so that you can prepare and help yourself for the next interview as a cloud engineer. After going through this video, you should have a good understanding about using and building apps and services with cloud computing. Also guys, if you are interested in an end-to-end course in cloud computing, Intellipaat provides the training in the same, and you can master all the concepts thoroughly. Now, without much delay, let's move on to the class.
Let's start off with a basic necessity. What is a salary that a cloud engineer actually earns, right? So let's talk about that. So what we have done is we have basically collected data from a lot of sites which basically do job postings. We have done it from ZipRecruiter, we have done it from Indeed, we have done it from Glassdoor, and this is what we have seen. So in the US, a cloud engineer, an average cloud engineer basically earns $128,000 per annum. In India, an average cloud engineer earns around 7 lakh rupees per annum. And in the UK, you have around 60,000 pounds per annum. Okay, so guys, this is an average salary. Now, based on your experience, let's say you have a 10 or 12 years of experience in the IT domain, and you plan on to shift onto the cloud sphere. In that case, you might even get a salary up to 20 plus lakhs per annum in India, right? I'm just talking about with the limited experience that I have. So I have friends who have salaries for 25 plus lakhs per annum, but that given that they also have a very strong background in the IT domain, right? I also have seen people who have basically shifted from non-IT domains and they started in the cloud sphere, and even in that case, given that you can implement what you have learned in your past experience in the cloud domain, they easily can grab a salary of around 12 to 15 lakhs based on their experience, right? So these are the two things that I talked about. The other thing is, it also depends, like I said, on your experience. And if you're a fresher and you're just starting out, and you're thinking of basically starting off with the cloud domain, you can easily earn around 4.5 to 5 lakhs per annum if you are a fresher, given you don't have any experience in the industry and you are just starting off as a cloud engineer in this space, right? So this is the salary that you get when you basically become a cloud engineer, and based on your experience, you can expect a different or a varied salary exposure. Okay, moving forward guys, now let's talk about the things which are important for you to get a higher salary. Now, how do you differentiate yourself from the people who are also there appearing for the same profile and are there in the interview room? So what differentiates you is your certification. So what are you certified with? Are you certified from AWS? Are you certified from Microsoft? Or are you certified from Google Cloud? Now, these are the top 3 cloud providers in the market right now. And each and every company who works on cloud would have their product on any of these cloud, right? And basically that is the reason any company who is basically expecting a cloud engineer in their firm, they would expect you to have a certification from either of these three, right? And once you get certified, that basically tells the company, okay, so now you're certified in this particular domain. We now know that you know cloud up till a particular proficiency, and then they start asking questions from that particular level. Now, this might not be helpful for some people who have a hybrid kind of a profile wherein they are working as a software developer full time and they also work on cloud for some part of their project, right? But if they try to shift their domain, they might get a job even without getting certified. That is also possible. But usually certification helps you when, let's say, you are working in a domain where cloud is not at all used, right? Let's say you're working as a system administrator, and let's say you're working for a company like IBM, which have their own private cloud. So what you don't have experience in, or what you cannot put in your resume, is that you have worked on AWS, you worked on GCP, you have worked on Azure on certain projects. That you cannot put. So for people like these, for people who don't have the working experience in these domains that are AWS, Microsoft Azure, and Google Cloud, if you are planning to become a cloud engineer, the first step would be to get certified in these cloud domains, right? So once you get certified, that basically tells the company, even though this person has not worked on production for these clouds, this guy has been basically certified by a parent body of the cloud provider. For in our case, let's just talk about AWS. So in case of AWS, the parent company is Amazon. So Amazon certifies this guy that he's proficient in their cloud infrastructure, right? And this is what the certification tells me. Now, on this certification, obviously, you'll have to also do some projects that you would be doing independently, and that you'll have to add to your resume. And that is how you will tell the company that you're appearing for that I have done some projects in cloud, although I did not get the time while I was working in my company in the production environment. But this is what I've done in the side time of mine, right? I've done these projects. And I've also got a certification from this company that I am a solution architect or a developer or an administrator, whichever certification you do, right? So a certification is very important. And with the certification, you can expect a salary hike, right? And the average salary, which we have discussed, this 139,000 is just a number. But whatever we discussed, you can aim for those salaries, given you don't have the experience in a current company with the certification. So you will have to get certified if you want to become a cloud engineer and you don't have the relevant experience right now. Okay?
Just a quick info, guys. If you want to become a certified professional in cloud computing, Intellipaat provides a training on the same, which covers all the concepts thoroughly. For further details, check the description box below. Now, let's continue with the class.
Moving forward, guys, now let me tell you some of the average salaries based on the certifications. So if you are an AWS certified solutions architect, in the US, you can expect around $130,000 per annum. If you are an AWS certified developer, you can expect around $130,000. And if you are a Microsoft Azure certified solutions architect, you can expect around $121,000. Now, all these salaries are basically the average salary. So what I can tell you is from $120,000 to $130,000 in the US, you can earn once you get certified by these companies and given you have the relevant experience. Okay. Now, you might have noticed over here that you have something called as a solutions architect, or you have something called as a developer, and all of these are basically certified by AWS. So what are these? Now guys, for the people who are from the IT domain, and if they want to make a shift to the cloud, and you also want to bring along with you the experience that you have in the IT industry, what you can do is, let's say you are a developer right now, okay, and what you want to do is you want to become or you want to do development in AWS with let's say you have an application on Node.js and you want that Node.js application to interact with some services on AWS. So what we'll have to know, you'll have to know some SDKs, you'll have to know how to interact with AWS APIs. So all that knowledge is basically gained by a person who is a AWS certified developer. When we compare him with a solutions architect, the solutions architect job is not to code. So most of the people that I've trained or that I know basically are solutions architect. The reason for that is when they started off in their IT journey, they did not know much about cloud, and they started off as a normal software engineer or a system admin or something like that. And now for the people who don't know coding, right, and they still want to be in cloud, people can easily crack the solutions architect profile. The reason for that is in the solutions architect profile, what you have to know is how to plan things. What you have to know is how to architect applications without happening or without knowing the actual implementation of the code. So that is what the solutions architect profile is. But mind you guys, this profile is super tough as well as you progress in your career. So you will find architects who were developers before, who were system admins before. They have the complete knowledge of the inside and out of the product. They can code also, and they also know how to plan. So those kind of people are also solutions architect, and obviously their salary are on the higher range. If I talk about a solutions architect who knows coding, who knows in and out of the application, and knows multiple clouds, his salary can go up to 40 plus lakhs per annum as well in India, right? So that is the kind of scope that you have when you get yourself acquainted with AWS. It's a journey that you'll have to start with, right? But you will even find solutions architect who are sitting at 4 or 5 lakhs per annum. And those people are basically freshers who have joined the industry and they just know AWS, right? You will also find solutions architect who are around 14 or 15 lakhs based on the experience that they had, and now they have shifted to cloud. So based on your experience, you can go up the ladder, right? The certified solutions architect associate is just a certification, but what matters is what experience you're bringing to the table, and that just makes everything change, or that makes the dice rolling when you're basically applying for a job. Okay, moving forward, guys. Now let's talk about what is the cloud engineer role. So we have talked about why you should be a cloud engineer, where I talked to guys about, we have talked about the money aspect. Let me also give you one more aspect, guys, that Forbes or some independent body, we are going to discuss about it in the future in the next couple of slides, but they have predicted that whatever revenue cloud is earning right now in 2019, by 2023, that revenue itself of the whole cloud industry is going to double, right? So that basically means whatever number of job postings that I'm going to show you today, they are going to basically double or triple by the year 2023 or 2025, right? So that's the kind of growth that cloud is going to see in the future. And if there is any time to shift to the cloud domain, it is right now, right? So if you are thinking about moving to the cloud domain, or if you want and are intrigued with what cloud is and you want a job in the cloud domain, right now is the time that you should migrate from your current job role to cloud, right? Now, what will you do when you become a cloud engineer? What exactly will be your role? Let's discuss that. Now, guys, a cloud engineer, or for my friends who are not acquainted with what cloud is, guys, cloud is nothing but, in the most simplest terms possible, it is the use of remote servers on the internet. Okay, so if you have remote servers on the internet and you use them from the comfort of your own laptop, you are basically on cloud. You're basically using servers which are not there in your premises. You are not, you're using servers which are away from you. So that means you're using the cloud. So don't get confused with what cloud means. Cloud basically means you don't know where the server exists. You just have an IP address, you have the username and the password, and you just type that and you can see the desktop of that machine and you can do anything you want. That is cloud, right? In the most simplest terms. But it gets a little complex when we talk about, so I talked about a server that would be existing on cloud that you can connect with, right? Now you have specialized servers in cloud which can do a particular task. For example, you have backend servers, you have front-end servers, you have database servers, and you can do a mix and match of these servers and create a whole ecosystem of application around you. So this is what a cloud engineer knows. He knows how to use the services provided by a cloud provider in the most optimum fashion possible, and create a highly available and highly reliable application out of it, right?
Just a quick info, guys. If you want to become a certified professional in cloud computing, Intellipaat provides a training on the same, which covers all the concepts thoroughly. For further details, check the description box below. Now, let's continue with the class.
Doesn't matter if you code the best application in the world, but if your infrastructure is not supporting your application, you won't get the kind of performance you want out of your application, right? And that is exactly why you need cloud engineers, because they know how to deploy your application. They know which server to deploy it on, or which service to use it on, use on cloud provider to deploy a particular application. If I were to give you an example of how it works from the top of my mind is, there are two backend languages. I'm not sure if everybody of you would have heard of it, but just hear to the example and you'll know what I'm talking about. So there is a programming language called PHP, and there's a programming language called Node.js. Now, Node.js basically works on single thread, while PHP works on multi-thread, right? So what happens is, when you have to choose between PHP and Node.js for your application, let's say you work in a company, and that company has made an application, the development team has made an application, and now they come to you asking, or they are planning to make an application, and they come to you asking, which programming language should we use? Should we use PHP or should we use Node.js? Now, you as an architect, you tell them that, if you're using PHP, it's a multi-threaded language. If you use Node.js, that's a single-threaded language. Now, this is something that you will find in any of the documentations. But what an architect needs to know is, what are the advantages of using single-thread language and what are the advantages of using a multi-thread language. When you use a single-thread language, you cannot give that language processing intensive tasks. For example, if there is one task that requires a lot of processing, that would not function well on Node.js, given it's a single threaded language, right? While on PHP, if there are multiple threads which can run at a single time, that particular language can accept process, an application which involves a lot of processing, right? But if your application does not have that much of a processing, it's just about doing CRUD operations on databases, right? In those kind of scenarios, you can use Node.js because it performs way better than PHP. Now, this knowledge which I just told you is a knowledge that an architect should know, right? Or a person who is handling a team or who's going to deploy your application on a particular infrastructure or in a particular environment should know. And this is similar to this knowledge in infrastructure, a cloud engineer should also know, right? For example, if my application is process intensive, if it requires a lot of processing, how much of RAM or how much of CPU would a single server require? That I have to plan. Which service on the cloud, like for example in AWS, there are three types of compute services mainly, right? You have EC2, you have Elastic Beanstalk, you have Lambda, right? So where to put which application you have to know. For example, Lambda requires backend or basically does backend processing for you, right? So backend part of your application would go on AWS Lambda. Now, obviously, if it's going on AWS Lambda, you'll also have to make it highly available. So AWS Lambda handles it for you, but when we talk about your front end, where a lot of users are going to ping your website, that task will basically requiring a lot of scaling up and down because the traffic is not the same at every time. What I basically mean by that is, let's say you are running a company and at around 4 p.m. you get the maximum traffic, right? So in that case, you need a server capacity of around 9 or 10 servers at that time. And at 6 p.m. the traffic drops. Okay, at that time you don't need those many servers. So how to configure the auto scaling properties in cloud providers, right? That and all this knowledge is what an architect gains when he basically gets certified, or when he roasts himself by doing work day in and day out as a cloud engineer, right? So guys, a cloud engineer role, to sum it up, is to know what application would go on what service of the cloud, and what would be the best practices of deploying an application. That is what a cloud engineer should know, right? Now, he has to work on planning, he has to work on architecting, then he also has to work on managing the infrastructure once it's deployed, and obviously he also has to look at how we can monitor and support this particular application. All this planning, all this implementation is done by the architect or the administrator or the developer, but essentially they are known as cloud engineers, and this is what your role would be when you shift into the cloud domain. So to sum it up, if you are applying the best practices and whatever principles you have learned in cloud, then that profile would sum up to become a cloud engineer profile. Now, moving forward, guys, let's talk about the skills that a cloud engineer should have, right? So a cloud engineer, or a person, if I'm a company and if I'm hiring a cloud engineer, I would expect certain skills out of a person. So I would expect he should know some programming language. I would expect he would know some Linux scripting skills that he should have. I would expect him to have some troubleshooting skills, and I would expect him to know multiple cloud domains. Now, this is not what I think the companies would expect. This is basically the research that we have done, and I'll show you in some moment, guys. I'll show you some job descriptions from companies who are basically hiring cloud engineers, and I'll show you what kind of skills that they ask. Right? So, how to become a cloud engineer? So, I told you guys some companies expect some skills. Now, how to get yourself acquainted in those skills? But before that, let me show you actually what are the requirements and skills that are expected from a cloud engineer. So guys, a job description is what we will be looking at. So in this particular section of job roles and responsibilities, I'll be showing you some job descriptions from multiple companies, and then we'll sum it up and see what are the required skills which the industry is demanding right now to become a cloud engineer. Okay, so let's start off with the first job description. So this is a job description which is by Cisco, right? And they are basically hiring a cloud infrastructure engineer, and what they expect this guy to know is DevOps. He should know how to resolve customer issues. That is, he should be customer centric, right? He should know how to deploy cloud applications on AWS. He should know about VPCs, which are basically services in AWS, EC2 again a service, etc. Right? So these are the skills that they expect from a cloud engineer. You would be wondering, what is DevOps over here, right? So I will explain that in a few moments. But as you can see, these are all the skills that they expect from a cloud engineer in the Cisco company. Now let's go ahead. Let's talk about Amazon. So Amazon is also hiring a cloud engineer, and what they expect is they should know troubleshooting. They should have experience with AWS, Google Cloud, Rackspace, software layer management, etc. They should know a programming language among Java, Perl, Ruby, or Python. And they should have experience in managing full stack applications. Right? This is the expectation from a cloud engineer by Amazon company. Then there is a company, McAfee, which I'm sure all of you know. Now in this, you are expected to know AWS, you're expected to know Azure, you're expected to know Google Cloud, right? You're expected to know CloudFormation, which is basically a service in AWS. You are expected to know Puppet, Ansible, and Chef, which are basically DevOps tools. You're expected to know Python, right? So all these skills are required. So what I'm trying to tell you is, it will not work if you just know one cloud provider. It will not work if you just know one programming language. You have to know a combination of multiple things, and only then this cloud engineer profile can be taken on. Okay, and more skills and more relevant you become with the job descriptions. For example, I'm not focusing on any one company. What I've done is I have generally taken out skills from multiple cloud engineer profiles, and then I have accumulated them together. Let me show you how that looks like. So the required skills are these. So if you were to sum it up, if you want to become a cloud engineer, you should have knowledge of AWS, Azure, and GCP, right? Then you should have experience in any of these programming languages, Python, Java, Go, R, Clojure. I would recommend you, if you are planning on to learn programming language, you should basically either learn Python or Go basically, because they are huge when it comes to the demand that they have right now. You should have a little experience in Linux operating systems, not a little actually. I'll say you should be an intermediate in your Linux skills. Then you should also have know tools like Puppet, Chef, Git, Docker, Kubernetes, Nagios, Terraform, etc. Right?
Just a quick info, guys. If you want to become a certified professional in cloud computing, Intellipaat provides a training on the same, which covers all the concepts thoroughly. For further details, check the description box below. Now, let's continue with the class.
So don't get scared, guys, with all these big words. I'm not only telling you the problem or what the companies expect, I'll also give you a solution as to how you can prepare for this. Okay, so, and you should also have an understanding of APIs and web services. Okay, so these are all the skills that are required to become a cloud engineer, and I would say even if you gauge around 60 to 70% of these skills, you can apply for a cloud engineer job. This is basically a job description for a generic company which is out there. Now, how relevant you become to become a cloud engineer is this list. The more and more you know this list, the more and more you become relevant, and you can apply for any cloud engineer job as you move along. Okay. Now, let's talk about what are the skills that we have summarized. So I've told you guys that you should know Linux. So first off, when you start on the journey of becoming a cloud engineer, you should start off by learning Linux. If you know Linux, you can skip this. But if you don't know Linux, first you should learn this, right? Then you should start off with all the cloud providers, that is AWS, Azure, and GCP. You should start learning that. Once you are done with Linux and cloud providers, you now know how things work on cloud. Okay. Now what you have to know is how companies implement or upload or basically help their development team to integrate their development tools with cloud, and that is exactly what DevOps is for. If I were to give you an example, let's say there's a developer in a company, and what he knows is basically a place where he can upload your code, right? For example, a developer's best friend is basically a version control system. Let's assume he is using GitHub, right? So all he knows is how to code and how to upload it on GitHub. But from GitHub, how do you test that application? And if the test is complete, how do you make it available on production? That life cycle is basically what DevOps caters to. Okay. Now, how does cloud fit in DevOps is when you have deployed an application on, let's say, your production server. Most of the companies now are basically using cloud, right? Which basically means they don't have any infrastructure of their own. Probably the developer's machine would be there in the company, but the server on which the application is deployed is not in the company, it's on the cloud. So I think you got the idea that whenever your applications are either getting deployed on testing server or on the prod server, these servers are nothing but these are servers which are deployed on the cloud, which could be either AWS, Azure, or GCP. So how to create the DevOps lifecycle on the cloud is what you'll have to learn. And that's why you also have the DevOps tools as a skill when you want to become a cloud engineer. Then you should also know a programming language. The reason for that is I told you guys a cloud engineer should also know how to code. The reason for that is, let's say an application stops working. right? And now the developers have no clue why it's not working. So it's your job to understand the code and understand where exactly the problem is occurring. And that's why it is recommended that you should know a programming language. Otherwise, if you're planning to aim for the cloud developer role, in that case, what you'll be doing is you basically will be implementing your application with the cloud, right? And if you're integrating your application with the cloud, which basically means you have to interact with the services of the cloud, then you have to know how to implement SDKs, right, in a programming language. And that exactly would be covered when you know a programming language, right? And finally, because today in today's world, we are no longer working with monolithic applications. What are monolithic applications? There is no one code which will basically run my whole application. You basically have different parts of the application deployed separately, and these different parts interact with each other. And these are what APIs are in the most simplest terms. Okay, so if you did not get that, let me just tell you in a brief sentence that earlier all the applications had one single code base and they were deployed and the application used to work. But what happened was, as we progressed in the software development journey, we realized that, let's say I'm using the Uber app and I have to add a feature in the payments section. So I'll have to open the whole code base again. I'll have to go to the payments section of the code and I'll have to make changes and then upload the whole code again. This unnecessarily broke something or the other in the whole code base. And now what we follow is a microservices architecture. And in the microservices architecture, what we do is we basically break the application into multiple parts, and then these parts interact with each other using API endpoints, right? So as a cloud engineer with the modern applications that we deploy, you should also know what are APIs. Okay, so these are the required skills for you to become a cloud engineer, and you should follow this particular fashion when you are basically preparing for a cloud engineer role. Okay. Now, I told you guys how you can prepare for a cloud engineer role, right? Now, if you were to do it on your own, this is the way. If you want help from us or from any e-learning company, I'll tell you a way as to how you can learn that as well. Okay, but before that, before we wrap up the session, I'd like to tell you guys the present is good. I mean, if you want to become a cloud engineer right now, it's the best possible time you can become. If you become right now, what is the future that lies in front of you? It should not be like that in 2-3 years the demand goes down, right? So let me tell you the future of a cloud engineer. So guys, these are basically some statements that I have picked up from these companies. Like Forbes says, cloud engineer or cloud architect profile is in the Forbes top 15 list of highest paying tech jobs right now. Right? Forbes says around $146,000 is the median salary for a cloud professional, which is basically a jump because when they did the survey in 2016, it was $22,000 less than the figure that you see right now. So as the number of years are passing by, the obviously the inflation is also there, but $22,000 is not the kind of inflation that you would see, guys. Right? So it's a huge jump in the median salary, in the average salary of a cloud engineer. Then according to Glassdoor, in the last month alone, right, we are talking right now in August 2019. So in July 2019, there were 5,765 jobs posted in India just for a cloud engineer. And there were 33,272 jobs which are posted that were in the US. Okay. So this is the huge demand that you can see that is there for a cloud engineer profile. Similarly, there's a company called Canalys. So they say AWS, which is the biggest cloud provider in the market right now, it owns around 31.5% of the cloud market share. Now you would think that 31.5 is not a huge number, but when you compare it with Azure, which is the second largest cloud provider, it has around 14 or 15% of the cloud market share, which is actually the half of what AWS owns. And it is the second largest cloud provider, Microsoft Azure. So as you can see, AWS has a whole lead. And the reason for telling you this is when you're planning to learn about the cloud providers, which I basically told you three, which are AWS, Azure, and GCP, you should always start with AWS, given you don't know AWS yet, right? The reason for that is once you learn AWS and let's say, you plan on going on with the other skills like the DevOps skills and the programming languages skills, you can actually skip Azure and GCP for a while. Because when you apply for jobs, 31 out of 100, 31 companies would be using AWS, 16 companies would be using Microsoft Azure, and if I were to go by my memory, around 8 to 9% or 6 to 7% is actually by the GCP. So out of 100, 31 companies AWS, 16 companies Microsoft Azure, and 6 to 7 companies would be Google Cloud. So this is the current figure. So if you go by probability, you are likely to get a job as a cloud engineer if you know AWS, then if you know Microsoft Azure and GCP. But our aim is to know all the three. But if you were to plan as to how to learn all the skills that we have discussed today, you should start with AWS. So this point is specifically for that. And finally, according to Report Linker, so this was the fact that I was talking about in the beginning of the session, that right now, the cloud industry has the revenue of around $258 billion annually, right? So by 2023, this is going to become $623.3 billion. That's more than the double of what the cloud industry is gaining right now, right? So this basically just tells us how much the cloud industry is going to grow in the future, all right? Moving forward, now let's talk about the job roles that you have in cloud. So I told you, you can become a cloud engineer, but actually a cloud engineer is basically a generic profile which companies post on the job portal. It is basically built up with a combination of job roles. So what are those job roles? So the first profile is solutions architect, which I told you about, wherein you have to plan, you have to know the in and out of your application. You should know which part of your application should be deployed on which service of the cloud. That job is basically the solutions architect job. Then you have the cloud developer. So cloud developer is a person who knows how to develop applications and also how to write SDKs so that the application can interact with the cloud services. So that's a guy who is a cloud developer. Then you have a person who is a SysOps administrator. A SysOps administrator is a person who basically manages the infrastructure once it has been deployed by the architecture, right? So once the infrastructure has been either designed or applied by the architect, the SysOps guy's job would be to implement that architecture or handle that architecture according to the norms that has been specified by the solutions architect. So this is what a SysOps administrator is. So for all my friends who have an experience in development and they feel that, I want to stay in development right now, I don't want to become a full stack cloud engineer, I basically want to be in development, but I would want some of my job to include cloud, then your profile that you're aiming for is cloud developer. For my friends who are already system administrators and they basically want to skill up themselves by becoming system administrators for a particular cloud provider, they can basically aim for the SysOps administrator profile. And for the people who want to move up the ladder, they basically have around 14 to 15 years of experience, either or basically they are from a non-IT background and they want to shift in the cloud domain. You should start off with the solutions architect profile. Okay, then I have some more profiles which are basically cloud network engineers. So people who are focused on just networking aspect of cloud. If you want to become a network guru, then in your case, you should opt for the cloud network engineer profile. And then you have the cloud DevOps engineer, which is basically a profile which basically expects you to know cloud in and out, which expects you to know DevOps in and out. And this is basically the profile that I was telling you about that you should aim for, right? You should know all the skills that are basically expected from a person who is a cloud engineer and basically then would become a generic cloud engineer who can apply to any company. So this is that guy. So your aim is this. If you want to start off from a particular point, your point would be this. You become a solutions architect first, get yourself certified in that, then work your way up for cloud DevOps engineer. And similarly, you can become a cloud developer or a SysOps administrator, and then you can get certified in cloud DevOps engineer. Similarly for cloud network engineer as well. Okay. Now we discussed all the jobs which are there in cloud. If you want to become a full stack, or if you want to implement cloud in your job, I just showed you some profiles which you can get certified in. Now some of my viewers today would be wondering, like, the current job that I am in right now, can I implement cloud in that? So let me show you some stats. So guys, the top 15 tech jobs which have the cloud related skills in the job description, that is what we are going to discuss right now. So guys, a software engineer, if you go by the generic job descriptions that we see every day, more and more software engineer job descriptions are expecting the software engineers to know cloud, which basically means if you are a software engineer right now and you are aiming for the future and you still want to be a software engineer, then almost 8 to 9% currently job description expects you to 8 to 9% of your job description. That means let's say you have 100 skills, out of those 10 skills should be in cloud, right? So this is what the 7.92 number means. Then you have the senior software engineer profile, which basically again expects you to have around 6.7% skills in cloud. Software architect expects you to have 6.21%. So basically the aim is to show you guys that all the profiles that you see over here, although they do not coincide with any cloud profile, still they have some elements of the cloud skills in their job description, which basically means most of the companies which are related to IT today are doing something or the other thing on cloud, and that's why they expect all their employees to know cloud. Right? So what I'm trying to tell you from this slide is, whatever profile you are in, if you want to be relevant to the industry, you should know, or you should start upgrading yourself with cloud today. Okay. Then these are some of the other profiles that you can have a look at. For example, a cloud engineer profile, a generic cloud engineer profile, a data engineer profile, a Java developer profile, system engineer, data scientist, then a system administrator, Java developer, .NET, front-end developer, back-end developer. All of these people, they have some element of cloud skills in the job description, and that is what you should aim for. If you are currently sitting in these profiles and you don't have this cloud skill, you should get started today. Now let's go ahead and talk about the cloud computing models, right? So what are the cloud computing models? What are the basically different business models on which the cloud companies are offering their services? Let's discuss about that. So there are two kind of models that cloud companies follow. One are called the deployment models, and the other are called the service models. Right? So these are two modes of business or two modes of services that you get in cloud. So let's discuss about them one by one. So let's talk about the deployment models first. So what is deployment models? How can you deploy your applications on cloud? What are the various ways you can deploy your applications on cloud? That is what deployment models are. Okay, so let's discuss them. So guys, the first option that you have in deployment models are public cloud. So what is public cloud? Public cloud is basically a place wherein you have one server rack. So let's talk about how cloud providers give you this awesome service of cloud computing, right? So let's say you as a company have launched around 20 servers on some cloud provider, right? And those 20 servers, let's say, are of the config, let's say 8 GB RAM and let's say 4 core CPUs, right? This is the config, and you've launched 20 such servers in cloud. Now, how do you think the cloud managers or the cloud providers who are giving you these 20 servers are managing these 20 servers on their infrastructure? How are these 20 servers managed on the cloud infrastructure? So for you, they are 20 different servers, but for the cloud provider, it's basically like one server rack. So what basically happens is there's a rack in which there are multiple servers which are installed. Okay, so each server, these cloud providers, they do not have specifications like 1 GB or 2 GB RAM servers. They have one server which has around 128 gig RAM and let's say 16 core CPUs. I'm just taking an example. So one server of theirs have this much of configuration. What they do is, on one of this server, they install virtual machines. So if you launched 20 virtual machines, it could be that these 20 virtual machines are there on one server of the cloud provider. I hope this point is clear, guys. So what happens is, cloud providers, they do not deal in machines which are of 1 GB or 2 GB size. They buy servers which are 128 gig RAM and 16 core CPUs. This is one server for them. But for us as end users, if we want a 1 GB machine, what they do is they virtualize multiple systems, or they create multiple virtual machines out of one server and they give it to us. Okay, so I as a company, if I've launched 20 servers, it could be that I am just on one server. I'm operating out of one server and I feel that I'm working with 20 servers, right? So for the cloud provider, they are just making or maintaining one server, and I feel that I've launched 20 servers and I'm working in them. So this is a basic business model of cloud, and that is how they earn. They charge you for 20 servers, but they're actually operating just one server, right? So when you are basically on this kind of an infrastructure, wherein the server that you are on, it could be some other customer also have launched their own virtual machine also on this server, right? So this is a public server in which anybody can have their own virtual machine, and hence it's called a public cloud. Okay, when you compare it with private cloud, what basically happens is, in private cloud, the cloud provider guarantees you that the server that your virtual machine exists on, it will not be shared by any other customer. And this is basically the case with companies which have very confidential data. Although the cloud providers guarantee that there will be no there will be no leak of data, or it will never be like if you are on the same server and you are working on one virtual machine and you can see the other person's virtual machine who's also on that server. It will never happen like that. But still, some companies, they have to meet their data requirements. They have some data policies, and according to their data policies, they do not want to be on a public cloud infrastructure. And that is when cloud providers say, okay, so what we are going to do is we're going to give you a separate server. No other application will be deployed on your server. It will be just your machines which will be launched on this particular server. So this is one type of private cloud. Then you have another type of private cloud also, in which basically your company buys their own servers, right? So instead of going to a cloud provider, they buy multiple servers, and these servers are then virtualized, and they are used as if you were using a cloud provider. And this is again done because of security purposes. When companies, they do not want to rely on companies like Google or Azure or AWS because they think their data might be stolen and it's very confidential. So in that case, they buy their own set of servers because probably money is not a problem for them, right? And from those servers, they launch multiple machines, just like how the cloud providers are doing. So that is also what private cloud is. And if you have heard about OpenStack, that is one such software which helps you to deploy a private cloud, right? But like I said, guys, there are two types of private clouds. You can get a private cloud from a cloud provider as well, wherein they promise you that your server will not be shared by any other guy, right? And the other type of private cloud is wherein you buy your own set of or stack of servers, and you treat it as a cloud for yourself, where you would virtually deploy multiple servers from each server also, and that is also called a private cloud, right? Then you have the third kind of cloud, which is called a hybrid cloud. Now, what is a hybrid cloud? In hybrid cloud, basically you have a mixture of public and private cloud, right? So that could basically mean that, let's say my company also deals in confidential data, and I also want a website to be hosted for my company. So what I'll do is, let's say the website accesses a database which I do not want to be there on public cloud. So what I can do is I deploy that database on the private cloud, and I deploy my application on the public cloud, because obviously with the definition you would have got that private cloud is obviously more expensive, right? And my website is anyways available to the whole world, so why not deploy it on public cloud? And all my confidential data can reside on the private cloud, and only my website can access the private cloud of mine. So this is also one kind of deployment that you have in the industry, and this kind of deployment is called a hybrid deployment of cloud. Okay, moving forward, guys, now let's talk about the service model. So we talked about three models in which there were three different modes of deploying our application. We had the public mode of deploying application, we had the private mode of deploying application, and then we have the hybrid mode of deploying applications. Now let's move ahead and talk about service models. So what are service models? So service models are basically the services that are given you by cloud, and you can choose which kind of service you want. For example, there are three kinds of services that can be given to you. You could be given infrastructure as a service by a cloud provider. You could be given platform as a service by the cloud provider, or you could be given software as a service by the cloud provider. Now, what does this mean? Now, we were talking about servers, right? So if you get a server for yourself, the whole server for yourself, you're basically getting an infrastructure, right? So that is called infrastructure as a service. So the service that the cloud provider is giving you is that it can give you machines to work on. When I say machines to work on, it will launch a machine for you, and you can go to that IP address, you can work on it. So you're getting the whole infrastructure, you're getting the whole machine, you're getting the access to the operating system, right? You can install any kind of application on it, and you can do whatever you want with that server. So this is what infrastructure as a service is. You get a physical machine that the cloud provider launches, which you can basically RDP or SSH into and then work. Then you have something called as platform as a service. So in platform as a service, you do not get access to any kind of server. So if I were to take an example, let's say you want to launch a website or you want to deploy a website. Okay, now there are two ways you can deploy a website. Either I give you a server where you install all the required environment applications, like for example, you install the web application softwares, and then you deploy a website onto it, and then you go ahead and see how it is doing and all, right? The other way to do it is that I do not give you access to the server, but what I tell you is, you know what, this is a website or this is a app that I've developed. All you have to do is you just click on the upload button and you specify the website code files that you have, and then you click on deploy. So what I'll do is I already have servers which have the necessary software installed. I'll put your website on my servers and I'll give you a IP address which you can go onto and see your website, right? So in this case, you do not have to manage all the softwares which will be installed on the servers. You do not have to manage about the size of the machine that you want to launch your website on. Everything is, abstracted from you, and you are basically just given an application through which you can upload a website, and which will result into giving you a IP address which if you go onto, you will see a website, right? So this is what platform as a service is, right? So instead of giving you machines, I'm giving you a dashboard where you can upload a website and then you can get your work done. So you do not have to worry about software installation and all. I'll do that for you. So this is platform as a service. So if I were to give you examples for this, let's say if you guys know about AWS, there's an application called Elastic Beanstalk, in which it gives you a dashboard. You upload your website, and that website gets hosted on a particular domain. You go to that domain, and you'll be able to see your website, right? The other example that I can give you is you would have seen there are a lot of websites which convert PDF to Word, right? So basically they do not ask you anything. You go on that website, you upload a PDF, you click on convert Word, your Word is downloaded, right? So that is again a platform wherein you do not have to download any software on your system and basically then put your PDFs into it, and then you'll get a software is already there on their servers. Just upload a PDF over there, you'll get the Word file. That is platform as a service. Then the third type of service that you get is software as a service. Now what is software as a service? Basically, imagine something like this, that let's say you go to Gmail, right? So when you go to Gmail, you're using the mail software which is given to you as a service. Or let's talk about Google Drive. So you have Microsoft Word, you have Microsoft PowerPoint, which you have to install on your system to work on, right? So instead of installing everything, what you do get is the same software on the internet as a service to you. So Google is giving you that as a service. So you can use the Google Docs, you can use Google PowerPoints, you can use Google Excel sheets. So all that you can use, and all that software is there on the cloud, and just by going onto your browser and browsing to their website, you get that as a service to yourself. So that is software as a service. So in terms of their services, there are three kinds of services. I'll just revisit again. Infrastructure as a service, when you get a server to work on. Platform as a service, where you get a dashboard and you can upload your work and see your work after that. And the third is software as a service, where you don't have to install any softwares on your system to use them. You basically get them from the cloud provider and you can use them as it is on your browser. The other example for software as a service is CRM. The Zoho CRM, for example, is again a popular software as a service which you can use in your company for sales purposes or managing records services, etc. Right? So these were the cloud computing models which exist out there. Now, if I were to differentiate between these three, as you can see, when you have your own computer, you have to manage everything from networking, storage, servers. If you have to do virtualization, then your operating system, middleware, runtime, data, application. This is when you're not using cloud computing, right? When you're using infrastructure as a service from cloud, you get networking, you get storage, you get servers, you get virtualization, and everything of this sort is managed by the vendor, right? You do not have to worry about it. Then you have something called as operating system, middleware, runtime, data, and application, which when you get infrastructure as a service, you have to manage everything, right? Every hardware component is managed by the vendor, but the software components you have to manage when you get a server from the cloud provider. When we talk about platform as a service, again, everything is managed by the cloud provider till the runtime environment, the operating system, everything is managed, but only your application you will have to upload and your data will have to upload, and everything else will be managed by the cloud provider. Then comes software as a service, where everything is managed by the vendor or your cloud provider. You just have to work on it, right? And then that is what a software as a service is. So guys, these were the three different cloud computing models that you have, which you can work on. Now let's go ahead and talk about, we talked about the cloud computing service. So a lot of people, a lot of companies give the cloud computing service. But now let's talk about the companies which give these cloud computing services to you, right? So if you were to get these kind of services, whom should you go to? So there are a lot of cloud providers, guys. The top three cloud providers are AWS, Microsoft Azure, and Google Cloud, right? So if you talk in terms of the market share, then AWS is on the top, followed by you have Microsoft Azure, and then we have the Google Cloud Platform. So these are the three top cloud providers in the market right now, which basically offer the cloud services, and they offer all the cloud services that we have discussed so far, right? Today in this session, what I'm going to do is I'm going to give you a taste of how it happens on the cloud, or how do you get started onto cloud. For example, we were talking about launching servers, right? So how do you launch servers on the cloud? So let me show you that. So let's start by going to AWS website, right? So let me just skip on to my browser and let's go to aws.amazon.com, right? So I'm on to the AWS website. Now the first thing that you do is you log in. So I already have an account. If you don't, you can just click on this orange button and then an AWS account will be created for you. So I have an AWS account which I'm going to log in right now. So it's the email ID for that is this, and the password for that would be this. Okay, So this gives you the AWS management console, and from here you can manage your infrastructure. Now, how can you manage your infrastructure? So I want to deploy a server. So what I'll have to do is I will have to go to EC2. So you will click on EC2. So EC2 is basically a service which basically gives you servers to work on. Now, as you can see, there are no running servers as of now. So what I can go do is I can just go click on running instances, and I can click on launch instance. And now I will be asked to choose an operating system that I want on my server. So let's say I want the Ubuntu server. Okay. So I clicked on the Ubuntu server, and now it is asking me what kind of specification or configuration do you want for your servers. Do you want a 1 vCPU and a 1 GB RAM? So yes, probably that would be enough. Then it'll ask you the network preferences. So if you do not want to get into the details, you can actually just leave everything at default, and you can straight away go ahead and click on review and launch. So now you can just verify if everything is according to what you want, and finally click on launch, right? Now, a good thing about AWS is, guys, that it gives you a free trial for 1 year, right? So for that, which basically means that for 1 year, you can launch servers for free, but only of a specific configuration, which is t2.micro. So that's what I'm doing. Right now, when you launch a new server, guys, so basically you have two kind of security mechanisms in place. One is you can either log in through password, which is the default way to do it. With AWS, it gives you a more secure way of logging in, which is using key pair, right? So you'll have to create a new key pair the first time when you're creating a server. So let's call it demo-AWS. Let's download it, and now let's launch the server. Okay, so my server is now getting launched. So it is in the pending state. It takes around a minute to launch a server. Let's name this server as AWS. And now we would want to connect to this server, right? Now, how do you connect to this particular server? What you do is you need softwares like Putty, right? So Putty is a SSH tool which you can use to connect to your server, and you also have a tool like PuttyGen, right? So you can just click on PuttyGen. PuttyGen basically converts your key file into a format which Putty can read, right? So right now it's in the PEM format. We will have to convert it into PPK format. So let's do that. So we'll go into load, we'll go to downloads, and now we'll have to select the PEM file. Now we'll save on the private key. Let's save it on the desktop, and let's name it as demo-AWS, right? So now if I go to my desktop, you can see that I have a PPK which is called demo-AWS, and this has just been converted by the PuttyGen. Now what I'll do is I'll go to Putty, which is basically this particular software, and over here I will have to enter the IP address. So this is the IP address of my server, which has now launched. As you can see, public IP. I copy this IP address and I'll paste it in this Putty terminal, right? And now I'll select the PPK file, so which is basically on the desktop, and the name is demo-AWS, right? I'll select it, I'll click on open, and it basically says that this is a new server that you're connecting to. Are you sure you want to connect to it? I'll say yes. And now it'll ask me the login for this server. So I've launched an Ubuntu operating system. So the login for this operating system is Ubuntu. I'll hit enter. And now I am in, right? So as you can see, I am inside the server. And now whatever I want, I can do with this server. So there are some commands like I can update the system, which will basically update the operating system. And then I can also launch a website over here, right? So let's say there is a web application software that I can install on it, which is basically Apache 2. So I can say sudo apt-get install Apache 2. So this is a software which basically helps you to host websites. So let me show you a very cool thing. So if we go to the security groups, you can see only port 22 is open as of now. When you use websites, or when you want to access websites from a server, what you have to do is you have to open port 80, right? So let's open port 80 over here, which is port HTTP, right? So port 80 will have to open, and who can access port 80? Anywhere, everyone in the world can access it. Let's click on save. And right now I've not installed the software. So basically if I go to the dashboard and try to type in this IP address on the browser, I would not be able to access anything. It'll say it refused to connect, right? But the moment I install the software, you would be able to see that my browser will show you a website which will basically be the Apache 2 software, right? So let's wait for this software to get installed. And now if I click on refresh, you can see that the Apache 2 Ubuntu default page we are able to see. So now this is a website which has been deployed on this server, and if I want, I can also change this website. I can just go to the folder where all the websites are, and now I can just remove the page which we are seeing on the browser, and I can add a new page, and I can just write a very simple HTML code over here which will basically show me a sample text which will say welcome to Intellipaat, right? And then I can close the body, I can close the HTML, and now I can just save this file. And if I go here and refresh, you can see I can see this website which is welcome to Intellipaat. So this is how easy it is to host a website with nothing but with AWS platform. If you were to do it by yourself, you would have to buy a computer on which you have a dedicated internet connection. You would have to buy a static IP address. This is a static IP address, right? Which basically means till the time I do not shut the system down, the IP address will remain the same. And in everybody in the world, even if you guys go to this IP address right now, you would be able to see this website, right? But that is not the case when you try to host it on from your personal computer, because your personal computer does not have a static IP address. You have to basically buy it from your ISP, right? So this is how you deploy a server on AWS, right? Now what I'm going to show you is, let's see if we can go ahead and deploy a server on Microsoft Azure. So I'll just go here and let me enter the the email address for it. Right, and now let me enter the password. So this is a personal account. So the password would be this. Right. So let me just enter the IP address again. The email address again. And now, this is my Azure dashboard, guys. So this is how my Azure dashboard looks like. You can see I have some services running over here. Now what I'll do is I will launch a server just like I launched in AWS. So I'll just go to virtual machines and I'll click on add a virtual machine, right? Now it'll take me through the same set of stuff that we went earlier on, with a little modifications, because every cloud provider is different, right? So over here I can choose what is the virtual machine name that I want to give. Let's say we call it Azure Life. Okay, so this is my server name. Where do I want to launch it in? You see in AWS I was in the Mumbai region. Here I can choose which region do I want to launch it in, right? So let's say I want to launch it in South India. Okay, then availability options, I don't want to give any redundancy. What is the operating system that I want to launch? Let's launch an Ubuntu server again, right? So what is the size of the machine that I want to give? So right now the size of the machine is 2 CPU and 8 gig memory. I can change the size, right? So you can choose what size do you need. So let's say we choose this size, 1 vCPU and 512 MB of RAM. Right, so let's select this. All right, now what is the authentication type? Do you want to log in through password, or do you want to log in through a public key as we just saw? So let's keep it simple. Let's select password. Let's give the username. We have the option of selecting a username. Let's keep the username as Azure, and let's give the password that I can remember. Okay, it says it's a little small, so I can just give a little longer password which can be accepted by this. Yes, so this is accepted. Now what are the inbound ports that I want to allow? So let's say I want to allow HTTP, and I also want to allow SSH because that is how I'll be logging in, right? So now let's go ahead and click on review plus create. And this is basically what we specified in AWS as well. So it says required information is missing or not valid. Okay, so basics, we did not select the resource group. So what happens in Azure is you can group your resources that you're launching. So let's put in a new group, which is AWS-live, right? Or I can just create here Azure-live, and I can click on OK, right? And now I can click on review plus create, and let's see. Yes, so now it says validation passed, so everything is well. Can you see the pricing over here, guys? It's 50 paisa per hour. This is in INR. It's 50.50 INR per hour. So that's how cheap cloud computing can be in terms of its pricing. Okay, so now let's finally hit create, right? And now it says your deployment is underway, so it will take some time, but I guess in the next 1.5 minutes you will have your server ready, and I'll show you how you can connect to it, right? So as you can see, the storage status is accepted, because that basically means that the Azure infrastructure is now deploying the Azure storage. It will then deploy the server, and this would be ready in just a minute. So network configurations are created. If we have a live IP which is created, the compute machine is now getting created, and now a deployment is created. Great. So now I can just go ahead, and what I can do is I can go to resource groups, and this is my resource group Azure-live, and what I have to do is I have to go to virtual machines, right? And on my virtual machines now, I can basically just go ahead and select the IP address. So the IP address is this. This is the IP address. Let's copy this IP address, and now let's try to connect to it. So I'll go to putty. I'll enter this IP address. So again, the same tool can be used to connect to it. I'll click on open. It says you're connecting to a new server. Is it okay? I'll say yes, it's okay. So what is the login as? The username that I gave was Azure, and the password is Azure right? And I'll hit enter. And now if everything goes well, I would be connected to my machine, and I am. Right, so now I'm connected to my machine, and again I can do anything with it. So I can just update this machine again, right? So this operating system is now getting updated, and once the operating system is updated, I can go ahead and I can install the same software that I actually did earlier, which was Apache 2, and see if I can see a website just like the way we saw on AWS. Okay, so while this is updating, let's just copy this IP address and let me paste it over here, right? So as you can see right now, it will say refuse to connect, And once I have installed the software here, you would be able to see that the website would be visible on this particular screen. So let's wait for this to complete. It is taking some time. Also guys, because probably the configuration of this server was 512 MB RAM, it could be a reason why, this particular process is taking more time, because obviously it is a little more slow than what we had in our earlier machines. So, okay, let me try one thing. Okay, so this is done. Let me see if it's updated. Sudo apt-get update, and if it was updated, it should finish pretty fast. It's a little slow because the resources are less. Yes, so it's updated. Now let's install the software. So sudo apt-get install Apache 2. And now it will install the software. A little slow, like I said, because of the resources. So let's give it a little time. It should be ready in the next, let's say, half a minute. All right, I think it's almost over. I think I should have chosen a higher spec for this machine, but never mind. I guess it's almost done, guys. Let's wait for it to complete. Okay, so it's actually complete. So as you can see on this IP address, I have the Apache 2 page now, which basically tells me that Apache 2 installation has been completed. It's still doing some stuff over here, probably because it's a little slow to update me, but yes, the Apache software has been installed. And now if I go ahead and if I change the the website by going into that particular folder, I would be able to have that same effect as I had in AWS. So if I go to this particular folder, I just have to remove this file, and I'll have to create one file which is going to be by the same name, and again an HTML, very simple HTML with an H1 which says welcome to Intellipaat, right? And now you would be able to see the same thing on the browser if I refresh, which says welcome to Intellipaat. Great guys, so now you have an idea of how to launch servers on AWS and Azure. Today in this session, we are going to discuss the top AWS questions that can be asked to you in your next AWS interview. So we'll start this session by first discussing the domains from which we have collated these questions. These domains are directly mapped to the AWS exam blueprint, which was recently updated. So there is a high possibility that your next AWS interview might contain questions from these domains. So I want you to pay the utmost attention that you can so that you can gain as much knowledge as you can from this session. All right, so let's take a top-down approach. Let's start from the simplest questions that are some generic questions on AWS that can be asked to you in an interview. All right. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You're basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now, you can think of it as, say, you want a deep learning AMI, or you want a Windows Server AMI with specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS Marketplace. So the answer for this is AWS Marketplace. It's basically a place where you can buy all the AWS systems that you, or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider, reason being that you're talking about the log of the client information, right? what all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. All right. So the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time, right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. All right, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are autoscaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each. and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elastic Cache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elastic Cache. So Elastic Cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elastic Cache, that data can be captured or can be cached inside Elastic Cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elastic Cache, and that is the exact use of Elastic Cache, right? So you use Elastic Cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an Elastic Cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the request to page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Request to page option to access via AWS billing, again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you're using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS, so there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2, right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are two types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite, that is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? All right, so to rephrase this question, basically you have an application which has two kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the tasks say should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the back end, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that a database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. All right. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS Edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places.
Just a quick info, guys. If you want to become a certified professional in cloud computing, Intellipaat provides a training on the same, which covers all the concepts thoroughly. For further details, check the description box below. I hope this video was helpful to you. If you do have any further queries, please comment below and we will get back to you immediately. So guys, thank you for watching the video.